In any complex system, truth is found at the singular point where chaotic, extreme fluctuations completely cancel each other out. This is the core of the philosophical middle way, or Zhongdao. It represents a state of total balance, positioned to avoid the friction inherent in extremes. Mathematical physics describes this state as stationary. It is the condition where a system reaches peak efficiency by eliminating every wasted variable. These philosophical tenets and mathematical operators share a structural logic, suggesting a unified description of how systems behave across different scales. We can trace this logic first through the central limit theorem in statistics, where the noise of individual variables eventually surrenders to the mean. It appears again in classical mechanics through the Lagrangian, which dictates the specific path of least physical action. And we find it in the subatomic world through Feynman's path integral, which resolves infinite, clashing histories into a single observable reality. This matrix maps these mathematically rigorous systems directly to their corresponding axioms. From probability to quantum field theory, the mathematical resolution is the same, the middle way. The universe optimizes for stability by eliminating extremes, structurally enforcing a centered path across all levels of reality. In classical mechanics, we can observe this by looking at how a particle or a planet determines its trajectory through space. This motion is governed by the Euler-Lagrange equation. L represents the Lagrangian, kinetic energy, T, minus potential energy, V. The equation acts as a scale. On one side is kinetic energy, the object's momentum. On the other is potential energy, the field's constraints. This balance is the mathematical equivalent of the Taoist principle of Wu Wei. Translated as effortless action, it describes movement that exists in perfect alignment with universal constraints. If a system exerts too much effort, excess kinetic energy pulls the trajectory toward the center. If it dips into a trough, kinetic energy pushes it back up. The stationary point occurs where this difference is zero. This path of least action is Wu Wei. At this specific path, wiggling the trajectory slightly yields no change in the total action. The system has achieved mathematical stability. Wu Wei is not inaction. It is the trajectory where opposing forces cancel, resulting in zero wasted physical effort. To see how this works at the subatomic level, we must look to Richard Feynman and the foundations of quantum mechanics. Feynman deconstructed the inherent chaos of particle histories through rigorous mathematical derivations. This chaos mirrors the threefold truth formulated by the philosopher Yi: provisionality, emptiness, and the middle. Feynman's premise aligns with provisionally. He showed that a quantum particle simultaneously takes an infinite number of provisional paths. Each path is assigned a phase vector, a complex number representing a rotation. The speed of this rotation is determined entirely by the action of that specific path history. On extreme paths, action values vary wildly, and vector arrows point in random, opposing directions. Summed together, they cancel out into zero through destructive interference. This is emptiness. Near the stationary point, vectors perfectly align. This constructive interference creates the middle, the single coherent path. The reality we experience is simply the middle that remains after the infinite extreme possibilities have canceled each other out. This principle scales upward from quantum particles to macroscopic populations. Taoism offers a warning about these dynamics. A violent wind does not last the whole morning. In statistics, these violent winds are extreme, highly improbable outliers. The central limit theorem proves that if you allow nature to run its course with enough variables, the data always forces a return to the mean. These individual chaotic points stack into a normal distribution. It is a probabilistic inevitability. The extreme tails of the curve are unsustainable, eclipsed by the massive gravitational density of the peak. This statistical center aligns perfectly with the path of least action found in the Lagrangian. It also overlaps perfectly with the vector of constructive interference from Feynman's quantum sum. Physical reality rejects extremes, gravitationally pulling toward a centered, optimized mathematical state. From quantum probability to classical trajectories and statistical populations, the mathematical engine of the universe enforces the middle way.